Hello everyone, today we are going to discuss the topic set theory. So if you look at set theory is a very relatively new branch of mathematics. So it was developed around 1860s or 70s onwards when George Cantor was working on a problem which was something like this. It was like a1 sin x plus a2 sin 2x and so on and so forth. So his name was George Cantor. So he was a German mathematician who was working on this sort of a problem. And then while doing this, he sort of created a new branch of mathematics, which is set theory. And today we are going to study more about this new branch of mathematics. While this is a newer branch of mathematics, but it has got a lot of application, and you would see that while you were learning relation and function, there will be a lot of application of set theory. Then you will also see that it has got application in probability and and then even calculus, right? So there are a lot of application of set theory, and that's the reason probably we are going to study set theory in much more detail. So since it's a new branch of mathematics, so there were lot of things which were defined in the beginning, and so we will try to understand all these new concepts and terminologies, and while we understand them and learn them, then it will become easier and easier for us to define further terms going forward. Alright, so let's start set theory, and the very first concept in set theory is called collection. So you will hear this term collection. So collection is taken from real life example. So whatever is available in nature. So you can see a pack of cards, like 52 cards in a pack, right? So it's a collection. Say students in a class, that's also a collection. A group of animals, it's also a collection. So collection, if you look at the collection, can be disparate as well as similar. So there can be multiple different things in a collection as well. So for example, I give this example a lot. Say while I am teaching, my teaching aids something like my pen, my notebook, my my whiteboard, everything, all of this is more like a collection for me. So it's a collection of items, right? So collection, I think you would have understood that collection is a term used to denote a group of something. So from this concept, there is something else which is built on, and this is the very first thing which is defined in set theory, and which is called set. So what is set? So set is a well-defined collection. All right, set is a well-defined collection. So it is building on top of a term which we already know. We know collection. Now set is being defined as a well-defined collection. So what do we mean by a well-defined collection? So a well-defined collection is something which is not dependent on people's perception. So what it means is that if say if say I am talking about some collection and someone else is talking about that collection, it will not depend on the other person or my perception, but rather it will depend on the way it is defined. So it's defined so well that either me or anyone else will arrive at the same conclusion whenever we are trying to understand whatever be the members or elements of the set. So yeah, so well-defined collection is a set. So first of all, as we said, collection. So collection was what? A group of something. So even all rivers of India would be kind of a collection. Rivers of India would be collection. As we said, students of our class would be a collection. Right? Now let's talk about a well-defined collection. Right? Say I say that collection of all students in class 10th of school Bal Bharti. So there is a school, Bal Bharti, and I'm talking about collection of all the students class 10th of school Bal Bharti. So say there will be, assuming that there will be 5 sections, there will be, in each section there will be say 60 students or something, and there will be almost 300 students. But if we know, if we understand Bal Bharti school and we know class 10th, then any of us would arrive at the same 300 number of students. It will not be that there will be some other student from other school will be included in this set. So this well-defined collection is a set. So it will be called a set. Similarly, in our earlier example, even all rivers of India, say all rivers of India would be my well-defined collection. Why? Because there, so all rivers of India may include say Ganga, it may as well include Yamuna, it may as well include Brahmaputra, it may as well include Narmada, Tapti and all that, right? Narmada, Tapti, Bhagirathi and or all the rivers there, right? But say someone comes and says that whether Nile is a part of this collection, whether Nile, which is a river in Egypt, so whether this is a part of this collection. So we know that since it is not flowing in India, so it's not going to be a part of this collection. So again, this is a set which is well defined because anyone who knows all the rivers of India will arrive at the same set of rivers which are flowing in India, right? But say I change this example a little and say that 5 most sacred rivers of India. Sacred rivers of India. Now this example is changed a little. Now I am talking about most sacred rivers of India. So say a person who belongs to North India might say that Ganga, Yamuna and Brahmaputra and all these rivers would be, there will be 2 more like say Son and then even Son Ganga, right? So all these 5 rivers, according to him, these are the 5 most sacred rivers. If someone is from maybe South India, for them it could be Narmada, Tapti, Godavari and all these rivers, right? So again this, if you look at this example, my 5 most sacred rivers will depend on perception to perception. Even in North India, there might be someone for whom Ganga might be more sacred, for someone Yamuna might be more sacred and stuff, right? So even persons from North India might arrive at a different kind of a collection. So this collection is not well defined. So this is not a set. So this is not going to be a set. So I hope you understood what is the well-defined collection and what is a set, right? So now let's move further and try to understand another concept as to how do we write this set, how do we identify what are the other rules of the set if we want to write a set. So all these members of collection, so they are either called members or they are called elements or they are called objects. So the members belonging to a set, they are called either members, elements and objects of the set. And while they are written, so while we represent a set with capital letters. So what do we mean? So we will write A equals to A, or set of collection of all rivers of India. So we are defining here there is a set A which is what? Which is a collection of all rivers of India. So this is how with capital letter. So a capital letter could be A, could be B, it could be P, it could be Q, it could be R, but just that it has to be a capital letter. Similarly, the elements of the sets, elements or objects which I defined earlier, elements of the set are represented 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 in small letters like A, E, B, C, D and something like that. So usually we do that, but at times you would see that people would write elements of the set in capital letters as well, and in NCERT itself we will see that. But yeah, usually we try to write elements of the set in a small letters. So for example, if let's say set A is a collection of vowels of English alphabet, then the elements would be A, E, I, O, U. So this is how we will write in small letters, right? Now we have understood how to represent the set, how to write the elements, and we also understood what are these elements or members or objects are called. Now we will try to understand how these sets are written. So there are actually two ways to represent sets, two ways to represent a set. So one we call it as roster form or tabular form. Another we call it as set builder form. Right? So we'll go to next page to write what is my tabular or roster form and what is my set builder form. So the tabular form. So when we list out all elements of the set, this is the one, and then this is one, then there will be these elements or objects. Elements are separated by comma, and thirdly they will be enclosed within curly braces. So what do we mean here is, as we defined earlier, A is the set of all vowels of English alphabet. So if we have to write it in this roster or tabular form, we will write it with two curly braces first. This is how we will start the set and end it, and then we will write elements like, we will write A, we will write E, we will write O, we will write O, we will write U. So these elements are written and separated by comma, and so we have to list out all elements. This is another thing. So we have listed out all the elements, we have not left out any element. These are only 5 vowels available, and we have written all the elements of the set. Same way, if we have to list out all the vowels, all the consonants, so we will write B, C, D, F, G, and so on and so forth. So we will have to write all the elements and include them within the curly braces. So this is what is called a tabular form. Now let's understand what is my set builder form. So even before that, there are a few things to be noted over here. There are a few things to be noted. One is that order in which the elements are written, the elements of the set are written, are immaterial. So what do we mean here? What we mean here is, if A is A, E, I, O, U, I can as well write it as A, E, O, U, I. So all that we are concerned about is the elements, all the elements should be there. We are not concerned about how these elements are written within the curly braces. It could be any order. I could write I here, E here, but these two sets in any case will be the same. There will not be any difference. And then second is that we generally do not repeat the elements of the set. Again, here what do we mean here is, say the same set A, if someone has written A, E, I, O, U, it's same as A, E, I, O, U. Why? Because E is repeated twice, and it doesn't matter, you should not be repeating it, but if you have repeated, it just means that I can just very well omit it and then write it like this. So there will be questions around it, that there will be something which will be repeated and you have to write it in a better form. So you could write it like this, but the better way to write it is like this, right? So these are two other points to be noted. Now, okay, let's go to the next page to write what is my set builder form. So we just learned what is my roster or tabular form. Now we are learning what is my set builder form. So even prior to going to set builder, I just want to explain you that, see, there will be lot of collections which cannot be represented using my roster or tabular form. So while we are writing my sets like this, right, you could see that there are examples I have written. They are generally like some English language related examples are there. So for example, I could even as well write over here set B is like, my set B is what? My set of all natural numbers, or set of all natural numbers less than say 10. So if you look at my set, this set will contain elements like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So there are 10 elements over here. But there could be sets like this also, like say someone is saying that set of, someone is saying that collection of all triangles in a plane. So this is also it's a collection, right? And if you have to represent it in this format, you cannot kind of like you cannot create like this, right? This is my right angle triangle, this is my equilateral, this is my obtuse angle triangle, and stuff like that, right? So this way it is difficult to represent, because even a right angle triangle can be of multiple variety. So for what I mean here is, for example, this right angle triangle might have sides like 3, 4 and 5, but there could be another bigger right angle triangle which will be again 6, 8 and 10, right? So there will be multiple such triangles, and while we want to represent it in this roster form, it becomes a little difficult. So this is where set builder form comes in handy. And what we do in set builder form is that we write the elements of the set in a form wherein these elements are connected by a row. So first let me write the definition and then we will try to understand it with an example as well. So when uh, elements of the set are connected by a common property which is not possessed by elements outside the set, this form of representation of a set is called set builder. So what do we mean here? So for example, the same example, if A being set of all vowels, right, collection of all vowels of English alphabet. So I could write it like this also, that X will, I'll explain what is this and how to write it. X, the set of all X is that X collection of all vowels. Or you could just write X as that X is a vowel of English alphabet. So your X is kind of a variable which changes every time you want to list out an element. So we read it like this. So this part is read like set of all and this part is read as X, and while we read it as such that. So how you read the entire stuff is set of all X such that X is a vowel of English alphabet. So this rule is defining that X, the variable, is such that it's a vowel of English alphabet. So we know all English alphabet, so we'll start writing, figuring out. Okay, so come to A. Oh, A is a vowel of English alphabet. So this will belong to this side. So I can write, oh, A is a vowel, and then it will. Oh, B. So B is B a vowel of English alphabet? No, so it will not belong here. Then C, no, it will not belong because not a vowel. D, no, it will not belong because it's not a vowel. E, yes, it belongs because it's a vowel, so we'll write E. And similarly, I, O, U. So while we define this property, so all these elements of this set possess this common property. What is this common property? That they are vowels of English alphabet, right? And any other element outside of this set will not possess the property. So B, C, D and E, these are not possessing this property. So of course they are not going to be part of this set. Similarly, even if we just talk about some random numbers 1, 2, 3 also, right? So they are, first of all, they are not English alphabet. So they are, first of all, they are not going to be part of this, right? So this is what it is saying, that when elements of the set are connected by a common property. So what is this common property? That they are being an English alphabet and being a vowel. So there are two conditions. First is an English alphabet and a vowel. So which is not possessed by elements outside the set, right? So any other element outside the set will not possess. So this set builder will make my life easier to represent any sort of set, right? So this is an example of my English alphabet. So let's take an example of some mathematical entities, right? So I can as well write, say these numbers are like this, right? So you have a number like, say there is a set defined like this: 1, 3, 5, 7, 9, 11. So, and this is what it is. So you can see these numbers are odd numbers, right? So you can see there is already a common theme going on over here. So what you can write this in a set builder form is, you can write, first of all, you try to find out the relationship. This is how you start. So you will start to find the relationship. So you see that, okay, can I write this as a variable or a kind of general term like 2 and minus 1? Can I write it like that? So 2n minus 1 when I write, when n becomes 1, when n becomes 1, then what will this 2n minus 1 become? 2n minus 1 will become 2 into 1 minus 1 equals to 1. When n becomes 2, then it will become 2 into 2 minus 1 equals to 3. And when n becomes say 6, then what it will become? 6 into 2 minus 1 equals to 11, right? So this is a common property which we have found. Now what all we have to do? We just have to write it in this format, wherein we will start set of all x such that x is what? X is equal to 2n minus 1. Alright, what is 2n minus 1? We have to define. So you can write it like this, where n is, where there is one way to write. You can write where n equals to say 1, 2, 3, 4, 5, 6. Right? So now you have defined a set wherein there is a root common property, and you have also defined that n equals to 1, 2, 3, 4, 5, 6. So if someone asks that, okay, does number 13 belongs to this set? So we will see, okay, 13. So first of all, what is my variable x? Or is there any value for which this will become 13? Yeah, for 7, n equals to 7, n equals to 7, my x will become 13. But actually n of equals to 7 is not part of this set, so 13 is not part of this set, right? Then someone will ask, okay, does 5 belongs to this set? Okay, yes, for n equals to 3, then my 2n minus 1 will become 5, so yes, so because of this reason, this will belong to this set, right? So this is what it is. So this is how we represent it. Generally, to represent anything which is not easily represented in roster form, we use set builder. But there will be a lot of questions asked to you, wherein you will be asked to convert one form into another, and something like a set builder form into a roster form into a set builder form, right? So in the next class, we will try to discuss exercise number 1.1 and try to solve some problems around it, right? If you have any questions, please ask in the comment section, and I will try to answer your question. Thank you so much.